Welcome guys to the new chapter on recursion. So what we'll be covering on this chapter is we'll be doing an overview of recursion. We'll have some few examples on recursion. Thereafter we'll have several interview questions regarding recursion. So recursion is the process by which a function calls itself either directly or indirectly, and the corresponding function is called a recursive function. Recursion makes the most sense whenever you need iterative branching. Recursion is a method of solving problems based on divide and conquer mentality, and the basic idea is that you take the original problem and divide it into smaller instances of itself till you solve the problem. So when you're dealing with recursive problems, you need to think of two things. That is your base case and your recursive core, right? And based on my belief, the recursive core is the most challenging part to come up with. So when you dealing with that, is you have to think of recursion in a mathematical way. So mathematics does proof by induction. So induction is they prove that a certain thing hold for a small instance, and then they can prove that if it holds for this small instance, it then holds for this big instance, and then they join everything together, and then they will have solved that bigger problem based on induction. So now let's go to our text editor, and then we get some few examples on recursion. Okay, so now that we're here in our text editor, now let's look at this Fibonacci sequence, then we try and come up with a recursive function that will give us this pattern, right? So for those who do not know, a Fibonacci sequence is a sequence like this. However, what makes it so special, or what makes it so different, is we have this primary numbers. Some people start with 1, some people start with 0. So but then we have those two primary numbers, that is 0 and 1, and then the next values we get them by adding this number plus that number, then we get 2. Then we add this 2 plus 1, we get 3. We add 3 plus 2, we get 5, so on and so on. We get that. So when we're dealing with recursion, we need our base cases, right? So we know that when our n, or value that we have, is 0, we know that we need to output 0. And then when our n is 1, we know that we need 1, right? So let's say define fib in n. So we can put that if n is equals to 0, we return 0, and if n is equals to 1, we return 1. And then else, we know that we have to add this value plus that value, right? So what we do is we know that we need to return our fib. Now we call our recursive function minus 2 plus the fib and minus 1, and then this should be our recursive function. Now let's try and print out this function. So we'll say for I in range, so for I in range, let's say 10, and then we say print fib of n, and then we can just put everything under one line of n. Hopefully this works. And then yeah, so let's print this out. Let's see, start this thing out. Print I meant print I. That was my mistake. So let's say I, because yeah, we're bound to get an error there. Let's just clear out this output. Let's rerun this code. Let's see. And then we actually get our sequence 0, 1, 1, 2, 3, that. This is our sequence. This is our Fibonacci sequence. Okay, so now that we're done with our Fibonacci sequence and we've seen, now let's look at one more example, and that is the factorial example. Now let's just create a new Python file. Let's say factorial.py. So factorials, for those who also do not know factorials, is, let's say I'm given 5 factorial. I know that my 5 factorial is 5 times 4 times 3 times 2 times 1. So this is 5 factorial, which will equate to 120, right? So we can look at this recursively. So we know that for something like this, we know that we have 5 times 4 factorial, right? So we're looking at something like this because 4 factorial is then 4 times 3 going down, right? So this is what we need. This is something that we need to keep in mind when we're dealing with such a function, right? So now let's come up with a function that will give us 120 if we type in 5 factorial, etc. So we define factorial. So we need a base case here that if our n is equal to 1, we then return that n, right? So we say if n is equal to 1, we return n. And then else, now our recursive function is, we know that we need to multiply this number with that number with that number, etc., etc. So we then say return n times the factorial of n minus 1, and then this should be our function. Let's say print factorial, and then let's pass in 5. Now let's just try and run this thing. Let's just comment out these lines so that we do not get errors. Just comment that out, and then we should be fine. So let's see. And then we do get our 20, right? So this is basically our factorial function. We can just try running another example. Let's just see. Let's say 4, and then we get our answer. So this is it with our recursion. On the next videos, we'll be looking at interview questions on recursion and solving problems with recursion. I hope you guys enjoyed this lecture or tutorial and you learned a lot. Please like, share, and subscribe, and hoping to see you guys in the next video. Goodbye.